Now let's deal with building materials. The architect has to look at the materials that he's using and choose them for their strengths, or perhaps the context or setting in which he's placing the building. And we'll start with the oldest of the building materials, stone. Now, stone, as we've talked about, lacks tensile strength, so you can't bend stone without it breaking. And when we build with stone without using any kind of mortar in between, it's known as Ashlar Masonry. And this is seen as a higher form of masonry. This is what we see from the ancient Greeks, the Incans, the Egyptians with the pyramid. The difference between ashlar and standard masonry is without the mortar, when we're doing ashlar masonry, any kind of imperfection can then translate through the layers and cause bigger and bigger problems as we build up higher. Imagine putting a pebble along a line of ashlar masonry bricks, and then you get a little lump there, and then it builds every time you put a new tier on top of it. And this could be stone, brick, or block. It doesn't have to be only stone. We consider the cinder blocks in your dorm room the same as we do the stone used by the Greeks. Then we have concrete. Now, one of these structures is known to suck the very soul, the dreams and aspirations of thousands of people away over history. The other one is the Colosseum. Yes, both Winter Hall on the UW-Whitewater campus and the Colosseum are built primarily of concrete. And this goes back to ancient Rome, although the Roman recipe was lost until the 19th century. The difference being the Romans would use a specific volcanic ash, which was incredibly difficult to reproduce or to work with once you get away from Italy. But concrete is incredibly useful. It is what's known as plastic. In other words, it will take any form I want it to. In fact, it's used to construct the Pantheon, amongst other Roman structures. So we're back to this structure again. Here, not only is the dome concrete, but the entire structure is actually concrete. They'll use it because of the speed of construction, but also for its strengths. And the walls at the Pantheon are up to 22 feet thick, so it's actually spectacularly useful in that way. You can create very small structures, very thin, light structures, or very thick structures, depending what you're doing. So it's great for weight bearing, but concrete ultimately lacks tensile strength as well as shear strength. So I can't bend concrete without breaking it, and I can't put shear forces where I'm pushing one side up and one side down on concrete without breaking it. But there's an answer to this. So we start with precast. These are concrete pieces that are cast in forms and then moved to the construction site. Now, oftentimes, inside of them, to make up for the lack of shear and tensile strength, they will add reinforcing rods, rebar, basically pieces of steel inside the concrete. Because whereas the steel is really horrible in compression, it's got great tensile strength and great shear strength. So it's just like using carbon fiber or fiberglass, where the material that we talk about, the carbon fiber, the fiberglass, is not that great of a material. As soon as you add epoxy to it, it's a phenomenal material. We get the same thing here with concrete. But it can go one step further. We can actually create prestressed concrete. I'll get to the reason for this in the next slide, but basically what I do is I stretch the iron that's going into it, I cast it, and then I release the tension. So if you have ever seen massive concrete girders going to a construction site, usually a highway construction site, you'll notice they all have an arch to them, just like this bottom version. There's a reason for that, which is this. Now, here we have reinforced and prestressed. And unloaded means there's no weight on it. So in an unloaded state, reinforced concrete is just flat, which you would think is what you want, whereas prestressed actually has that arch to it. But as soon as I put a load on, so imagine I've got a truck driving across it. In the case of the reinforced, it's going to bend down, and that's going to fracture the underside. Eventually, these fractures will get larger, concrete will fall out, it will weaken and collapse, sort of like the Hone Bridge did a few years ago. Whereas prestressed, because it's already got the arch in it, as soon as my truck drives across it, then it just goes to level, which doesn't put any undue burden on the lower surface, which means it's going to survive for longer. Then we have wood. Now, wood is fantastic for small applications. If I'm building a cabin, for example, wood is fantastic. Concrete or stone would probably be overkill. But you don't see wood in commercial construction. And there's a couple of reasons for this. First of all, wood is highly flammable. This is a problem if I'm building something quite large with a lot of people in it. Secondly, wood lacks a lot of the strength, a lot of the compression strength that we see from other materials, which means I can only build so high before the wood itself is too heavy for the wood at the base to support. So, great for small structures, not so good for larger structures. Also, with new construction techniques, we can take wood and create almost any shape with it, which has made it more useful in construction, but again, in construction of small spaces, not of large commercial complexes. And then we have steel. Now, we use steel in buildings all the time. That's what the skeleton frame in many of the high-rises in, say, Chicago, Milwaukee, or wherever else are made of. We also see it used a lot in bridges. Steel is introduced in the late 18th century, where they start to refine iron to the point that it's strong enough to use for these massive pieces of architecture. And it should be considered different from iron. It's a modified form. It has reasonable compression, but it has great shear and tensile strength, which is why we use it in certain applications. So it's got its strengths as well as its weaknesses. There are also newer materials that are starting to be used, where we're seeing styrofoam used in pre-insulated panels. We're seeing carbon fiber being used in some small architectural elements that will probably expand. We see a lot of new materials coming up. So this is always changing. This is just a basic primer of the materials you're likely to come across in most buildings.